because people can be.
Okay. Hello and welcome back to another episode of Streaming School. So I'm glad that you've come back, and we're lucky enough to have Bucky Yusuf with us today, who is going to be taking us through a range of items to do with chemistry. Welcome back, Bucky. How are you? How was your weekend?
Thank you. Welcome back. No, good. Very relaxing. Completely switched off, so I'm ready to go for another week of lockdown and learning.
You were saying just before that it's been our most beautiful April in the world, and the humans haven't been around. So
Exactly.
coincidence or the shape of things to come?
I think so, yeah. Nature having a laugh at us.
Perfect. Right, the screen is yours. Let us know when you want to switch over to your screen and we'll go from there.
All right, okay, thank you. So good afternoon, everyone. My name is Bucky Yusuf. I'm going to be starting your third chemistry lesson. And could you switch over, please?
Perfect. Done.
Okay, great. So what you should see on your screens, if you join me in the previous lessons, is a reminder and recap of what we looked at last time, the changes of state. So the three states are solids, liquids, and gases, as you can see on the screen. And you've got 4 boxes which represent how these states can change and the processes are linked. So to go from a solid to a liquid, it's melting, liquid to a gas, evaporating. If you cool down from a gas to a liquid, however, that's condensation. And when we go from a liquid to a solid, that is freezing. So that just basically links to our previous lesson when we looked at the changes of state, and lesson before that when we looked at the 3 states of matter. So quick fire 5 again. Those of you that joined me last lesson will remember that at the start of every lesson, we will recap what we covered, just to keep it fresh in our minds, and just to see how quickly we can actually explain the answers. So if you're joining in with your exercise book or even a sheet of paper, or even a device, mobile, whatever you want to write on, just write numbers 1 to 5. This is the only time I'm going to ever ask you just to write down a one-word sentence, or even a one-word answer, or even a sentence that's not very clear, not very long, but it's clear to you. So these 5 questions, how quickly can you answer them? What are the states and symbols for the 3 states of matter? Which state of matter is the least dense? What is a chemical change? Now, number 4 is what we had before. So I remember how many of you can remember what does the kinetic theory of matter mean? And number 5, what are the limitations of the particle model for solid, liquid, and gas? Now, normally when you do this, or if you're watching this on replay, you can actually pause at this point and give yourself about 3 minutes just to see how much you can quickly remember. But for the sake of this video, if you're watching it live, we're going to go through the answers very quickly, okay? So in brackets, you will see SLG in lowercase. So if you ever write a chemical equation and you need to write that in the states of matter, these are the symbols that you'd write in lowercase. The gas is the least dense of all of the materials, which basically means it's the lightest. Chemical change is one which is irreversible. So it basically means that you cannot go back to what you started with. And not only can't go back, what you end up with, your compound or product, looks completely different to the materials that you started with. The kinetic theory of matter, basically it used to explain the particles and models of liquids, solids, and gases, and it describes their properties. And the limitations, 2 main ones, if you did the homework from lesson 1, the particles are not always the same size. So when you draw it, we draw them as the same size, but in real life, that is not the case. And the forces of attraction are not shown. So today we're going to move on to a slightly different topic, but it links to our previous 2, where we're looking at elements and compounds. And what we're going to do is review elements, compounds, and properties of simple compounds. Now you'll notice with the do now, it's asking you to name 3 simple compounds. And if you're struggling with that, then look at the second part here, where you've got a list of different substances, and you've got to work out whether or not they represent a compound or an element. You don't need to worry about whether you know them. Can you identify which ones are elements and compounds? Now, if you find that very straightforward and easy, the challenge is here. Water has covalent bonds. When ice melts or water evaporates, do the bonds in water break? Explain your answer. And at the bottom, we've got a number of keywords that we're going to be using in our answers and explanations today. So, how did you get on with the do now activity? In blue, you've got all the different substances that were listed in the previous slide. And we're now going to look at which ones represent an element and which ones represent compounds. How many did you identify? So hydrogen, H2, element. Carbon dioxide, CO2, compounds. Oxygen, O2. Methane, CH4, compounds. Hydrochloric acid, HCl. And just to clarify, because some people think this is an I, chlorine is represented by the chemical symbol capital C, lowercase l. So this actually is an L. Lithium, Li, is an example of an element. Carbon monoxide, CO, is another example of a compound. And fluorine, F2, is an element. And lastly, ammonia, NH3, is another example of a compound. Sulfuric acid again. And sodium, Na. Is there anything that you noticed about the compounds and how they might look different to these elements listed here? Whether the elements have got a small number next to them or not. It's the case with lithium and sodium. Okay, so that takes us up to the next point. In our previous lessons, when we looked at solid liquids and gases, we represented the particles as circles. But we need to remember that all substances are made of atoms, and it's linked to the periodic table. So you've got gold, represented by the chemical symbol here. And if we were to magnify the atoms in gold, this is what we'd see. All the atoms would be exactly the same, and there'll be gold atoms. So every single element that you see in a periodic table is made up of atoms. We've got three different other examples of elements, and this is just to reinforce the fact that no matter which element you look at, whether it's this, whatever this bucket is made out of, or this black substance here, or the gases that have been filled inside these balloons, when you magnify it, all the atoms will be the same. So you've got copper atoms only, carbon atoms only, and helium atoms only as well. Going back to our do now activity, you will notice that some of the elements are represented as one letter, say Al, Na, Li. So it basically means that you're looking at elements that have only got one atom, as indicated here by these orange circles. For other substances like O2, H2, N2, they had a number next to the letter. And these elements are joined atoms. And there can be other examples as well, but we just looked at those just to introduce it to you. So whenever you look at any atom, whether it's a single atom or joined together, they are only made up of one type of atom, and they cannot be broken down into anything simpler. We will look at what an atom is made out of, but by itself, it's the only unit that can exist. Now, when we look at compounds, however, we'll notice something slightly different. The compound is made up of two or more types of atoms that are joined together, and they are joined together by chemical bonds. That is why it's irreversible. You cannot go back to what you started with. And here's another concept to be introducing to you, molecules. Now, if you have a compound that is made up of non-metal elements, say, for example, carbon and oxygen, what you get is also known as a molecule. Okay, and that's what is represented by these diagrams here. So, making a compound really quickly. Iron and sulfur. Some of you may have seen this in some of the practicals you've done before. We will represent the iron as the grey particles here, solid, regular shape. Sulfur as well is also solid with a regular shape as well. What we're going to try and do is make a compound, so basically joining these two elements together to make a compound of iron sulfide. Now, iron is magnetic, and that's the reason why we've got a magnet there to prove that it's magnetic. When you put iron next to the element sulfur, it doesn't move because sulfur is not magnetic. If you were to mix iron and sulfur together, the iron can come out because it's not chemically joined to the sulfur. It's only when you heat the two elements together that you form a different substance that is not magnetic. So this is different to the ion you started with, and it's different to the sulfur you started with. It's a completely different compound, which shows that you've got something that is new, that is made, and it cannot go back to the sulfur or the ion that you started with. And this is just another way to represent what I just explained, but more importantly, to also show the particle diagrams. Okay, so when you heat it, chemical reaction is actually happening. The iron and sulfur mixture is being heated. You have the atoms that are rearranged to make a new compound, and it is no longer magnetic. So I'm going to pause for a bit and get you thinking. So I said about using particle diagrams that can be used to represent elements or even compounds. So with these 5 diagrams here, doesn't matter, you don't need to worry about what these particles represent. All you need to think about is whether it represents an element or a compound. I'm going to pause here to get you to think, how did we define an element? And how did we define a compound? How would they visually be different to each other if you drew them as particles or a particle diagram? Okay, so if you're watching this on replay, you can pause, give yourself a couple of minutes. But for the sake of the video, we're going to move on. So I hope you identified correctly that if you've got 2 or more different atoms that are joined together, you have an example of a compound. What about this one here? They're both joined, but they're blue atoms, which means that you're looking at an element. Here, you've got red and yellow circles, or atoms, particles joined together, the compounds. These red particles are all the same element, and these yellow particles are all the same element again. Now, I put that in there because some people find it difficult to identify the particles correctly as elements or compounds, and that's just one way you can actually look at it. Now, we're going to take it up another level to something that some students find a little bit difficult, to try and identify using chemical symbols, whether you're looking at compounds or elements. And the challenge is to try and work out how many atoms are in each substance that you see on the screen. Now, there are 6 different substances, so we're going to do 2 things. Which ones are elements or compounds? And then how many atoms are there? Now, for those of you watching this on replay, give yourself 5 minutes to give yourself the time to really work through what you're seeing here. I'm going to give you a hint. If you're really struggling, if you've got a copy of the periodic table, which of these elements by themselves can you see on the periodic table? Okay, let's go through the answers. Now, with this one here, you've got hydrogen, you've got number 2 by it, and you've also got oxygen. And I've written it underneath, HO. These are the atoms. 2 or more atoms joined together tells you it's a compound, and there are 3 atoms that you can see at this particular compound here. You've got Ca for calcium, you've got 1 C, carbon, and 3 oxygens. So it's against the compound, and you've got 5 atoms. What about this one here? What do you think this substance is? Now, because there are only hydrogen, you can only see hydrogen there, there's 2 that here, 2 there, which basically means that there are 4 hydrogen atoms, it's an element, and there's 4 atoms there. This one here is the chemical formula for glucose. Should be easy to see, it's a compound, and that there are 24 atoms. What about this one here for carbon dioxide? 1 carbon atom, 2 oxygen atoms, give you 3 atoms altogether for a compound. And last but not least, nitrogen. Okay, element with 2 atoms. Okay, so just to end on another point, you might be thinking, oh my goodness, there's a lot of information. What I'm doing is trying to connect and knit all the different things we've looked at before, the states of matter, changes of state, and the properties of the substances you actually look at. Now, these 3 represent simple covalent compounds, and they were linked to the Duno. 3 of those were linked to the Duno activity we looked at the start. The reason why ammonia is highlighted in blue is because of the fact that this represents the ammonia molecule. It's a simple covalent compound. And you can see two things. Inside the molecule, there are bonds or lines between the hydrogen and the nitrogen, okay? And they are called intramolecular bonds. They're part of covalent bonding. And we will look at that in more detail next time. But you'll notice that between each of those molecules, you've got intermolecular forces. And these forces are actually quite weak. Why? And that's the reason why, because you're looking at a gas, and that is part of the reason why it is so easy to actually separate these molecules. It basically means it's got a low, a weak intermolecular force, therefore a low melting point or low boiling point. Okay, so today we're just going to go with just one exam question. I've given you a lot of information today, and one exam question. So sodium chloride's melting point is 801 degrees C. Its boiling point is 1,413 degrees C. On this basis, complete the table below. What does it mean? You've got 3 temperatures here, and you've got to work out whether each of those temperatures will represent sodium chloride as a solid, as a liquid, or as a gas. And here's a hint before we actually look at the answers. When you talk about melting point, you are going from a solid to a liquid. Remember that concept we looked at last lesson, melting point. Another hint before we actually look at the answer. When you're going from boiling point, you are looking at going from a liquid to a gas. So use those 2 keys. You have got a melting point going from a liquid, from solid to a liquid at 800. So anything below 800, what would that be? Anything above 800, what would that be? And you've got a boiling point. So when it goes from a liquid to a gas, is the boiling point. In this case, it's 1,413. So anything above that, what would it be? So liquid or gas. And hopefully you've worked out that above, 1,800 degrees C is a gas. 400, it will still be a solid. And 805 degrees C, the sodium chloride will be a liquid. Let's review. What did you do well in that question? And what do you need to improve? Now, I've put the information into the table because a lot of students find it difficult to understand the information when it's represented as a table. So you may understand the topic, but not when it's presented like that. So it may be something that you need to improve upon, how to read information when it's presented as a table. So quickly wrap up. What are the 3 key words from this lesson that you think are most important? From those 3 key words, what do 2 of those words mean? And what is one thing that will help you next lesson? Now, I always end on a fascinating aspect or further thinking for you to actually consider. Now, the Weird Science YouTube channel actually has a short video. Now, it's relatively longer than the other ones. It's about 7.5 to 8 minutes, but it gives you examples of 13 fascinating elements. And all I want you to think of is this. Which of those 13 elements is the most interesting to you and why? Thank you very much. I hope to see you next lesson.
Thank you so much, Bookie. Thank you so much, Bookie. It's really, really appreciated. That was, how did you feel about that one? You flew through that one.
Yeah, I enjoyed that.
There you go. The online revolution of learning continues.
Okay, so I'll just stop sharing the screen now.
That's perfect. Thank you so much. Have a great day, and look forward to seeing you sooner rather than later.
Okay, take care. Have a great day. Bye.
Bye.
Hey, Denise, that was really nice to put together, wasn't it?
Yeah, that was actually.
Yeah,
I was thinking, this would have helped me when I was doing my GCSE.
We should just call Ofsted and be like, yeah, Ofsted, we've been observing all these lessons now. We can tell you a lot about online learning and how things work and how things don't work and stuff. But yeah, I will leave you to lead out for the last of the day.
All right, thank you. Here is the optional task for chemistry today. There are 2 questions. Number 1 is state the 2 types of covalent compounds, and number 2 is explain how covalent compounds are different to ionic compounds. Hopefully you got that from this session. There will be all the videos on Facebook and YouTube, so you can catch up on them if you missed out on anything or any previous lessons. And I will put the resources to any links to any resources and the questions on Facebook and YouTube. And we have another website down here that will be links as well. And if you join, see if you watch these again and again, you notice this happens. And there's a code, it's NEON3, which I'll put on Facebook and YouTube as well. You'll be able to catch up the results on there as. That's it for today. I hope you enjoyed.
Brilliant. Thank you so much, Nish. Really, really appreciate it. I look forward to seeing you tomorrow.
Yep, see you tomorrow.